All right, last naming, acids. Okay, an acid is anything that produces H plus ions when it's dissolved in water, the hydrogen ion. Okay, that's how you know you have a an acid. So if there is, so the hydrogen ion is your cation. Okay, and it has to be dissolved in water, which is called aqueous. You'll see this AQ everywhere. Okay, so in this case, you don't have a metal cation. Hydrogen is your cation. If hydrogen is your cation, you've got an acid, and you now have to use acid rules. Okay, so there's a whole bunch of rules here, but we'll talk about them when we get to the problems. Okay, so this is what's called binary acids. This page. All right. Hold on one second. Okay, these are binary acids. How do I know the binary? They're just two different elements, a hydrogen in all of them. See, they all start with hydrogen. That's how you know you have an acid, when hydrogen is in front. Okay, and then you have a second atom after it. Okay, with the exception of hydrogen, there's always an exception. All right, and okay, so this is the acid name. So when do you use the binary name and when do you use the acid name? I'm going to make this so simple, guys. Don't ever call it the binary name. Just erase this from your head. If you ever see something with a hydrogen in front, use the acid way of naming it. So if it's a binary acid, you put hydro in front, followed by the prefix, and end it in ic acid. Okay, so hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, hydrocyanic acid. This is one of the polyatomics. It's one of the only polyatomics. All right, hydrosulfuric acid. Don't call it hydrogen sulfide. Okay, now usually you will see an AQ following it. You'll see like HCl AQ. Okay, then you know it's hydrochloric acid. Okay, only for the binaries. When you start putting polyatomics with it, with this exception, there's always exceptions, aren't there? If you have a binary acid, it's what's called an oxyacid, then you're going to use different rules, and I believe that's probably the next slide. Yes. Okay, oxoacids. These now are when you have one of the polyatomic ions, one of the eights or one of the ites. Okay, if you have an acid that uses one of the 8 ions, okay, you name it as an ic acid. You do not use hydro. So for example, let's say HClO3. So the ClO3 minus ion is chlorate. Okay, so it's an 8, so I use ic. So this is called chloric acid. Okay, remember the binary is hydrochloric acid. Don't confuse chloric acid with hydrochloric acid. Okay, so if it's the 8 version, you use ite, you do not use hydro. If it's the ite, you use us. So HClO2, okay, so HClO2 comes from ClO2 minus ion, which is the chlorite ion. So we're going to name it in us. So this is called chlorous acid. All right, either chloric acid, chlorous acid, or hydrochloric acid. Okay, the way I remembered it is I ate an acid and it was icky. How cool is that, huh? I ate an acid and it was icky. Ate goes with ick. And then I just remembered that us goes with ite, or ite goes with us, however you want to remember it. I just remembered the 8 and the ick. Okay? And then the pers and the hypos go correspondingly as well. All right? So let's do a practice. Put this on pause. Practice determining if it's going to be a polyatomic oxo acid, oxoanion, or if it's just going to be a binary. Okay? Welcome back. All right? This is going to be an oxo. How do I know? Well, there's an oxygen. I also have 3 different atoms. I have more than 2. Okay, notice there are 3 different atoms. This only has 2. So this is going to be the binary acid rules. This is going to be the oxo acid rules, the icky one. Okay, so HClO2. Well, this is going to be the ClO2. I know is chlorite. All right, so us goes with chlorite, so this is called chlorous acid. All right, hopefully you got that. H2CO3. This is carbonate. Carbonate. How do I know that? I looked back on my list. Go back to your list. Oh, I passed it. Nope, I didn't. Go back to your polyatomic chart. And the carbonate, 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 carbonate. Where are you? There it is. Carbonate right there. CO3 2 minus. So H2CO3. Whoa, got way ahead of myself there. So carbonate ion. So it's going to be carbonic. This is going to end in ic. So this is called carbonic acid. But wait a minute, why isn't it called hydrocarbonic acid? You should be able to answer that. Why is this not hydrocarbonic acid? Because this is an oxyacid. It's using one of the polyatomic ions. Finally, H2S. Binary or oxo? Binary. So I'm going to put hydro now in front of it. Hydrosulfuric acid. Okay? So just remember, guys, these videos are the nuts and bolts just to kind of get the lecture material. Really, the learning is in class. Okay? I'm giving you enough information to start your homework and to start learning. All right? All right, this is kind of a review. All right, an element is a substance that contains only one type of atom. Elements may exist as independent atoms, such as helium, or as a molecule, such as O2 or CO2. All right, most elements, including metals and noble gases, exist as isolated atoms. Okay, nonmetals generally exist as molecules, many of which as diatomic molecules. All right, a compound is a substance consisting of more than one atom. So sodium chloride, water, that's a compound. All right. How do you determine between ionic and molecular? Should be pretty easy. Ionic has a cation and an anion. Molecular is all non-metals. Okay, so here, metal, non-metal, ionic, metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal. All right, ionic. Okay, they can consist of binary, which these are all examples of binaries, or with polyatomic ions in them. See, they all have polyatomic ions. There are some exceptions, and the exceptions is the ammonium ion. Okay, that's one of the nonmetals that is a cation. Okay, and covalent bonds or molecules are only nonmetals. So Hi, CS2, N2O, CLI, CF2. All right. One other thing before we get to this, I forgot to mention it. There is NO2, and then there is NO2 minus. This is kind of the summary of this whole entire page. These two are not even close to the same thing. Boy, do they look like the same thing, but they're not close. This is a neutral charge molecular compound with all covalent bonding. This is called nitrogen dioxide. This is the nitrite ion. This can form an ionic bond. This cannot. Okay. This is a great example of kind of a summary of this page. All right. You have two things which exist, same number of nitrogens and oxygens, but one has a negative charge and the other does not have a charge at all. Okay. They have different naming rules. They have different properties. Everything is different. Okay. Here's kind of a flow chart. There's a few flow charts here to kind of help you with the naming. Some people really like these. They like to follow it. This is kind of what you have to have going on inside your brain. Okay. Does the ionic compound have an ammonium? Okay. If yes, then ammonium, whatever, ammonium. So this is naming polyatomic ions. Okay. Actually, it's naming everything. Okay. Let's say no, it doesn't. Okay. Does it have a metal? Yes. Okay. Does the metal have more than one possible charge? Like, is it a transition metal or a post-transition metal? Then you follow these rules. No, it does not. It's like sodium. It only has one charge. So then you follow these rules. So this kind of breaks it up. Okay. All right. Is there a metal? Okay. Or is it ammonium? Yes, follow these rules. Very simple. Is it not? No. Is it a transition metal? No. Go here. Is it transition metal? Yes. So this is type 1. This is type 2. All right. This is now ammonium, type ammonium. All right. And then it continues further, okay, of how to, and so but basically, if it does have no metal, I think you know it has no metal. So here's part 3. Then you name it as either the non-metal types like nitrogen monoxide or however you want, okay, or an acid if you have it as an acid. All right, hopefully a lot of this made sense, but like I said, the understanding for this really comes from doing lots of problems. You kind of learn along the way. There's lots of information here, okay? I've talked about every little nuance. Now it's just a matter of you kind of learning it as you go along, okay? So do those problems and ask questions, and I will see you in chapter 4.